Hey, fourth graders, going to give you a short science lesson. Today we're talking about the Earth and Moon and how they're related. So I'm going to read this along with you. Your goal today, as we read along, is, again, I'm going to put this as a discussion. I want you to put down something that you learned today or something that you found super interesting. So you might want to have a pencil and pen along, or pencil and paper, so that you can write down whatever it is that you think is interesting. You might need to rewind me. So, what is the moon like? On many nights, the moon appears to be the largest, brightest object in the sky. Unlike stars, however, the moon does not make its own light. Why does the moon shine? It reflects the light of the sun. Moonlight is reflected sunlight. So, if you can remember back from previous weeks, the Earth sits here like this, and I will put North Dakota facing us. Right now we're probably sitting something like that. And right now it would be daytime, if the sun is out here it would be daytime. But what's really happening is the light from the sun hits the moon and reflects back to Earth. So if you can imagine, I'm going to move North Dakota to nighttime. Here the sun would be hitting this side of the Earth, and the light from the sun comes and it hits the moon and it reflects back to us here. Why some nights you don't see the moon, we'll get to that in a little bit. I'm going to say that. So the moon does not make its own light. Rather, what you're seeing when you see the moon all lit up at night is you are seeing sunlight bouncing off the moon. And here's the diagram of that. Now obviously the Earth is much smaller than that compared to the sun, and the moon is a little bit smaller than that compared to Earth, but what they're showing you is that the sunlight is hitting here on this half of the Earth. Over on this half where it's nighttime, the sunlight that's coming from up at this angle hits the moon, and it's being reflected in all different angles, but some of that sunlight is being reflected back to Earth, and that's why you would see why we have moonlight. Come on, next page. There we go. Okay. The moon is Earth's closest neighbor. In space, it's about 384,000 kilometers, or 240,000 miles from Earth. Yet, this is almost 400 times closer to Earth than the sun. So if you think about that, what that's basically telling you is, if on a model, if the Earth is here and the moon is right here, this distance in between, from here to here, 400 of those distances. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'd have to count 400. It's maybe a half a centimeter. It'd be like 200 centimeters. If the Earth sits here, and the moon sits here, and that's a half a centimeter, it would be like having 2 meter sticks away. So it'd be, you guys can imagine my classroom, it would be like almost over to the door, is how far away the sun would be from the Earth in this diagram. Rocks on the moon are similar to some Earth rocks. However, there are many differences between Earth and the moon. For one, the moon is much smaller than Earth. There is no air or atmosphere. It has almost no water either. Not wanting to work today. Because of these factors, the moon has an extreme range of temperatures. In the daytime, it is hot enough to boil water. The nights are colder than any place on Earth. It's no wonder the moon does not support life. Surface features. The moon has a few tall mountains. It also has flat plains, but most of its surface is covered with craters. A crater is a hollow area or pit in the ground. Large rocks called meteoroids made many of the moon's craters. Meteoroids travel through space. They often crash into other objects. Craters in Earth's atmosphere. If meteoroids are always crashing into things, why isn't Earth covered with craters? Earth's atmosphere keeps them away. When a meteoroid enters Earth's atmosphere, they become very hot, and most of them burn up before they hit the surface. So, we talked about the moon does not have an atmosphere. So, here I'm going to draw a couple pictures, and okay, so there's Earth, let's say. Leave Antarctica down there, blue and white. Very detailed picture. And over here, we have the moon, okay? We talked about how the moon does not have an atmosphere. So when little meteorites, or even big meteorites, are in a collision course with the moon, there's nothing to stop them. They just crash into the moon and they shoot some moon debris up into the sky. Some of it maybe gets up into space. I don't know how far it goes. Probably depends on the size of the meteorite. But what it would leave behind, if you could zoom in, would be a crater. Or if you were looking at it from this side, that's why when we draw it, kind of looks like a chocolate chip cookie, but they're little divots in the moon. For example, let's go back here and let's take a look at this picture. Oh, I'm going to go up this time. If you look, you can see the craters, like right there where it hit. And these bigger areas, you know, there's another crater right there, there's another crater. All these little circles that you see are craters. Well, on Earth, we have this invisible layer of protection all around us. This is not a very good picture, but it's the best that I can do, called the atmosphere, okay? And in the reality, the moon's a lot farther away from our atmosphere. The atmosphere is densely packed air particles, okay? And when a meteorite is on a collision course for Earth, they enter into this atmosphere, and it's a lot thicker than this, and what happens is it creates friction. We've talked about friction, that friction produces heat. There's friction between that meteoroid and the atmosphere. And that friction, if you can envision this, here's your meteorite, is trying to push through this atmosphere, and as it's doing that, all those air particles are going around it, and it actually creates, that's how shooting stars work, creates a little bit of a fire and a tail behind it. When you see a shooting star, it's a meteorite being burned up in our atmosphere. And as it goes through that, that burning burns this up and makes it smaller and smaller and smaller. And sometimes they come through there and they're no bigger than a speck of sand. Sometimes they're completely gone. You know, the bigger the meteoroid, the bigger the piece that can make it through. Okay? So it'd have to be a pretty big meteoroid to get through our atmosphere. Now this next part, if we can ever get the page to change, there we go. This has to do with phases of the moon. And it's why at different times you can see parts of the moon, or see the moon at night, and not at others. So the moon goes through this sequence. So if you can imagine, here, I'm bringing my Earth back, hopefully we can see that. I'm going to make sure that it's in the picture here. Yeah, it's kind of tough to see, but you'll get the picture here. So we always are going to imagine that the sun's shining from this side, okay? So this is always the day side, the side facing the computer. If the moon is over here, it's going to receive full sunlight. You could see all of the moon because all of the moon is lit. Now I'm going to have to move this a little bit. But if I move this over here, and the sun still shines on it, it's a little harder to do. You would see, well basically the point of this is if the sun was on this side, because there's not the sun, the moon's always going around. If the moon was on this side, you're not going to be able to see it because it's on the same side as the day. the side of the moon that's lit up faces the sun. But if it's on this side of the earth, this side of the moon is going to be lit up from the sun and you're going to be able to see it. Now, likewise, if it's over here at nighttime, you're going to see at any given time, half of the moon can be lit up. As you can see, half of the moon is more bright. Here the full front of it is lit up. If I shine from the back, you get some gets through here, but you can see now that it's darker. And this time, the half facing the flashlight to my right is lit up. So it depends on how much of the moon you see depends on where the moon is in the cycle. If it's to the daytime side, you don't see it at all. That's the new moon. If it's over this way, it's going to be getting a little bit bigger. That's the waxing crescent. Then you're going to see a half moon, or a quarter moon rather, excuse me. But when it's a quarter moon, you see half of it. Then here you'd see a waxing gibbous. This would be a full moon, waning gibbous, third quarter moon, waning gibbous. And then back to new moon. It's easier to show you these things when you're at school, but I'm doing the best I can. Come on. Nope, I don't want 374 yet. I want 373. So, what are the phases of the moon? Like the sun, the moon seems to rise and set. The sun does not move around the earth, but the moon does. As Earth revolves around the sun, the moon revolves around Earth. It completes one orbit around Earth in just over 29 days. This is almost as long as an average month. In fact, some of the earliest calendars were based on moon motions. As the moon orbits Earth, its appearance seems to change. The apparent shapes of the moon in the sky are called phases. During one complete orbit, the moon cycles through all of its phases. At the same time, the moon completes one rotation. All this time, the sun is shining. It lights one half of the moon at a time. The other half is dark. During the moon's orbits, we see different fractions of its lit moon. The moon's gravity. The moon has gravity. It pulls slightly on Earth. On the side of the Earth that faces the moon, the water or land bulges slightly outward. The moon pulls more than the sun because it's closer to Earth. The moon's gravity causes tides. Tides are the daily rise and fall of the ocean surface. Most coasts on Earth have high and low tides. So I'm going to show you kind of how that works. Picture. So you got to imagine that it's round, this is Earth, but here's a beach. Over on this side it's a continent. And then you have your ocean would stretch like this. Okay. And so here's your ocean. Okay? If the moon is on your side of the Earth, so let's say the moon is right here. We know that any two objects have gravity, and the bigger the object, the more gravity it has. So the Earth is pulling this way, but the moon is also pulling towards itself. So what would happen if the moon is on your side is this middle part of the ocean would lift a little bit, causing this part of the ocean to come down a little bit. Think about it, I always tell kids, think about like if you took a sheet, if you were able to do this and put it on a bed, and then were able to kind of hang over it and grab the sheet in the middle and lift. All the corners of the sheet would come up as you grab that. But unlike the water, when you let the sheet go, it doesn't just go back perfect. When the moon goes away, or is on the other side of the Earth, it comes back up to the normal water level again. Alright, 374. This is probably the coolest part of this, I think. Talking about eclipses. So there's two kinds of eclipses. There's a lunar eclipse, and what a lunar eclipse is when you have sun, earth, moon. And a solar eclipse is when you have sun, moon, earth. Solar eclipses are, seeing those are a little bit more rare probably, or seeing full solar eclipses than seeing lunar eclipses. We just had one here not too long ago, a few years ago. I'd have to look up when that was, when you could see it. What is an eclipse? An eclipse occurs when a shadow is cast by Earth or the moon. The diagram shows the two basic kinds. In a lunar eclipse, Earth casts a shadow on the moon. This happens when Earth is directly between the sun and the moon. The moon passes through Earth's shadow. Solar eclipses. In a solar eclipse, the moon casts a shadow on Earth. Solar eclipses happen only during the new moon. A partial solar eclipse is when part of the sun is blocked. A total solar eclipse blocks all of the sun. Eclipse safety. Only a lunar eclipse is safe to observe. Looking at a solar eclipse will damage your eyes or cause blindness. Sunglasses do not help. For this reason, you should never look directly at the sun during an eclipse. Scientists use special tools to observe solar eclipses safely. Okay, so let's take a look at what an eclipse looks like. So here we've got our Earth. And here I've got a moon, and here's my sun. So if you look on a solar eclipse, what's happening, hopefully you can see the shadow being cast there. That would be like having a solar eclipse. Passes in between. You can see how it enters the light. I'm going to put North America towards us there. And you can see that if I was shining this, you can see the shadow. I'm not tipping it correctly here. Let me get shining it at my hand. That's the problem. Right there, you can see the ball or darkness pass across that. Now, in a lunar eclipse, what's going to happen is, as the moon crosses behind the sun, it's going to be in between the Earth and the sun, and you're not going to be able to see the light. But when it comes back around, you'd be able to see it. It's kind of harder to show you guys when you're not here, so I apologize for that. But the difference would be that on a lunar eclipse, you're going to lose the light of the moon. You're going to not be able to see the moon, or the moon's going to look dark, and then the moon will come back. You'll see like kind of a glow around it. So anyhow, make sure you comment on something that you learned today. Take care.